All right, so homework 4 is due on Wednesday before class. Then on Friday, we won't have an in-person meeting. There will just be a lecture video that's posted for our class on Friday. And then a week from today, we're going to have our first midterm exam. So 7 days from now, you'll have me giving you this equation sheet, which is the factor equations. I'll give you any factor tables that you need. And then you'll also need to bring your computer to use Microsoft Excel. And you can prepare, if you choose, 1 page of notes. You can put anything on that page you want. It can be formulas, definitions, like procedures on how to use Excel for a certain thing, whatever kind of reminders or pep talk you want to give yourself on the equation sheet, feel free to do that. Yeah?
The notes have to be handwritten, or can we make it like on a...
Can be whatever you want, letter size.
Back?
Yep, that's right. Other questions? All right. Today we're going to talk about future worth analysis and annual worth analysis. And remember, when it says analysis, that generally means that you're comparing alternatives. And so a method is what you use to find the present value or the future value. But then analysis means applying a decision criteria to choose between multiple options. So just as a review, when we talked about present worth analysis, the decision criteria there is that when cash flows are discounted to the present at the minimum attractive rate of return, then you would choose the alternative with the highest non-negative present worth. Just as one exception to that, sometimes you would choose an alternative that has a negative present worth if you don't have a choice and a project has to move forward. There could be options that both alternatives are negative, in which case you'd choose the least negative alternative. And I think that's the situation on the homework. I think one of the homework problems, you've got 2 options, both of them you're losing money, but we just assume in that case you've got to choose one of them, and so you'd choose the alternative where you lose the least amount of money. So that's what this next bullet point is saying, is that if you only have the cost data, then you'd select the alternative with the lowest present value of costs. And that's when you assume that one of the options has to be selected. So present worth analysis. You take all of the money over time to the present. And when we have alternatives with different useful lives, we sometimes have to do things to sync it up. If you've got one alternative that lasts for 6 years and another one lasts for 9, you can't compare the alternatives directly. You have to do something to make the same study period for both alternatives. So the 3 approaches we used for that was by cycling the cash flow diagrams until they both end at the same year, and that's the LCM approach. We would use contract services in order to lengthen the shorter of the 2 alternatives. And then we use early termination to truncate the longer of the 2 options by selling the item at the end of the first alternative's useful life for some salvage value or resale value. So that's what we talked about last week on Wednesday and Friday. We can also apply these same techniques when we're doing things other than the present value. You'll notice that here, in all the examples we worked so far, we were comparing the alternatives in terms of what would be their lump sum present equivalents. We can also apply these same 3 techniques when we're doing future worth analysis. So future worth analysis is exactly like present worth analysis, except for instead of finding a lump sum value at time 0, you'd be finding the lump sum at some unspecified future year. And so you can see here's 2 alternatives. One of them lasts 4 years, one of them lasts 5. And for future worth analysis, what we tried to do is find out if instead of taking it all to the present value, if we found a lump sum in some future year, then how could we compare those 2 alternatives? So again, we have the same restriction that we have to have the same study period when we apply future worth analysis. So it wouldn't be okay to compare these 2 directly. We'd either have to apply LCM or contract services or early termination to compare these two alternatives, because you can see the first option lasts for 4 years and the second lasts for 5. So we have to make sure that the alternatives end at the same time. You'd use this approach in the real world on large projects where the revenue only starts to be received after several years of investment. So airports take a really long time to build, for example. And during the construction period, the construction phase may be financed by a bank or a consortium of municipalities. And so they've got all these outflows over time, and they have to know sometimes if they're going to sell the project to an investor, what would be the lump sum that is equivalent to all of their expenses up until that time. So that's what this would maybe represent, is you're spending money, spending money, spending money for several periods. Now, how much is the economic equivalent amount in the future if you're going to sell a project that's finally been completed? So that can also apply to toll roads or sometimes large construction projects with buildings when you've had several years of operations and you want to know what's the lump sum value at some time in the future. Now, decision criteria, if we're comparing alternatives, we need to know what is the rule that applies for how to know whether you choose one option or the other. And it's very similar to what we've done before. In present worth analysis, remember what we were doing is discounting values to the present. Here this says we're compounding values to the future. Compounding just means moving the money forward in time into the future. And again, what you do is you'd choose the alternative with the highest non-negative future worth. And that's when you assume that the do-nothing alternative is valid, meaning that the projects don't necessarily have to be completed. But if you have cost-only alternatives, which only have outflows, and the project is necessary, then what you do is you choose the least negative of the future values. So the approach is very similar. It's just we're calculating future values. So today's in-class exercise, we're going to get some additional practice finding future worths. Another thing we're going to do in today's in-class exercise is calculate the annual worth. Now, let's look at this cash flow diagram. This is showing that we buy some equipment at year 0, and then it looks like maybe this is in millions. And so if this was in millions, we're buying the equipment for $8 million in year 0, and then spending $5 million in the first year to refurbish the equipment. And then there's $0.9 million of operation and calibration expenses. And then at the end of the item's useful life, we have some minor, minuscule salvage value that we get from selling the equipment or scrapping it. Now, sometimes it's inconvenient for companies to have big jumps in the amount of their cash outflows over time. And so what they'd rather do than spending $8 million one year and then 5 and then only 0.9, if they want to kind of smooth out their cash flow situation, then they'll find ways by financing a project to just find the annual equivalent of it. Because it's much easier for them to, instead of dealing with the wild swings in outflows, to just have more or less every outflow be the same. And individual people do the same thing oftentimes with their energy bills. A lot of people pay way more during the winter months for electricity or propane or heating oil than they do during the summer. And so a lot of utilities will let you take an annual average and just pay the same amount every year so that they don't have those seasonal swings. So here what we could do is find the annual equivalent of this entire cash flow. So think about if you're going to find the annual series of these individual components, how you do that. Now obviously the 0.9 million is already an annual series, and so we wouldn't need to do anything with that. But there are other pieces here like the salvage value in year 8, the refurbishment cost in year 1, the initial purchase price at times 0. All those things we'd have to find A for the amount. And so with this first one, here at year 8, you've got a couple of different ways that you could deal with it. You could find A given F, or you could take it 2 times 0, and then once it's there, you could find A given P. So it can sometimes be a multi-step process, and we have to think by writing an outline of our solution strategy how we do that. Now take this amount in year 1. If you wanted to annualize that, you couldn't just immediately find A given P because it's not in the present. So this would be a 2-step process to find the annual equivalent of the $5 million refurbishment cost. What you'd have to do is find P given F and then take it to year 0. And once it's combined with the $8 million that's already at year 0, you could find A given P. So keep those solution strategies in mind. The nice thing about annual worth analysis is that when you have the annual equivalent of alternatives, there's no need to use things like LCM to unify the study period. And so if you're finding the annual equivalent, you can compare alternatives that have different useful lives. Because by finding the annual equivalent, you're effectively making the study period the same. So that's one advantage of the annual worth analysis. And the decision criteria is choose the alternative with the highest positive, meaning non-negative, annual worth. So if you find all the annual basis when you've used the MAR as the interest rate, choose the alternative with the highest non-negative annual worth. So equipment that's going to be replaced frequently is sometimes commonly paid for on an annual basis. Software is increasingly being paid on an annual basis rather than lump sum purchases. Like in the past, you'd buy Microsoft Word, maybe it would be $300, and then you just use it as long as you want until it became obsolete. And you know, if you had purchased Microsoft Word 2010, you might use it until Microsoft Word 2017 came out and you wanted to upgrade to the new version. Nowadays, instead of that, what people most typically do is subscribe to Microsoft Office 365 and they pay an annual fee and then they just upgrade the software every year and as it becomes available. And so people these days are annualizing software and thinking of it as a service rather than as a product that they buy once and then never pay for again. Just like the other decision criteria, if you have options where only costs are provided and the option is obligatory, where it's not an optional project, where it has to be one or the other, then you just choose the alternative with the least negative annual worth. So any questions about annual worth analysis? Like I've mentioned, the advantage of doing things with the annual worth analysis is that you only have to calculate the effect of one cycle. You can have different study periods because it automatically is assuming repeatability when you compare alternatives with the annual worth method. So because of that built-in assumption, then you have to assume that you need the equipment for at least the LCM of the alternatives. And so you don't actually have to calculate the LCM, but if you have one option that's 3 years and one option that's 7 years, if you're using the annual worth method to compare them, then the only way to compare them using annual worth would be to assume that both of them would be needed for at least 21 years. And so because of that repeatability assumption, it assumes that all the cash flows would be the same in subsequent life cycles. And so if those things aren't true, if you know that your two alternatives aren't going to be used for the LCM, or if the cash flows are going to be changing over time and you only want to compare alternatives for a shorter time horizon, then it would be better to use a method besides annual worth. It would be better to use like present worth and then either early termination or contract services to compare them. Okay, the last thing we're going to work on in today's in-class exercise is the idea of capital recovery. Capital recovery is the annualized difference between the purchase price and the salvage value of a piece of equipment. So that is, if you know that you're going to have to pay a certain amount to buy equipment, and then you're going to be able to sell it sometime in the future. So you've got a purchase cost at the present, a sales price that you're going to have an inflow some year in the future. The capital recovery is the amount that is the annualized equivalent of the outflow and the inflow. And so to find the capital recovery here, you would find A given the P of the capital cost. You'd find A given an F of the salvage value and the difference between the two. So you can see that this arrow is pointing down, and that's because almost inevitably equipment costs more to purchase than you're going to get as a salvage or sales price for it in the future. It's very, very uncommon that you'll be able to sell equipment in the future for more than you paid initially to buy it. So usually the capital recovery is an outflow. Sometimes though we want to know how much new revenue we'd have to make in order to cover the cost of the equipment. And so if the question asks you how much new revenue do you have to earn in order to cover the capital recovery costs, then the revenue would be an inflow. So just remember, this can sometimes come into the idea of differences in perspective. The capital recovery itself is negative, but to have balance between capital recovery and profitability, then the revenue required would be an inflow. So we'll get some exposure to that with the in-class exercise today. Any questions about what I mean by capital recovery? This is one of the things that people always seem to forget between now and the exam. In an exam, if I asked you to calculate the capital recovery for some item, all you'd have to do is annualize the purchase price, annualize the salvage value, and combine them together. It's pretty simple, but just somehow or another, it seems like it always slips through the cracks, and there's a huge proportion of students who forget what I mean by capital recovery. So hopefully that won't happen this semester. All right, let me hand out the in-class exercise for today. Okay, we're going to work on this one together at the same time. I'm going to pull up Excel. We need Excel for this first problem. So you do the same. If you've got your computer today, and hopefully you do, open up Excel. And I want to show you a couple of things we can do to format this and make it look nice. Did everybody get a copy of the handout? Okay. So let me copy this and paste it into my spreadsheet so we can all look at it together. All right, so just to practice good habits here, this is in-class exercise 12. Remember, we talked about annotation in the last class period, problem 1. Okay, so we'll define the interest rate. And in this problem, it says the interest rate's 7%, 0.07. And now, for a future worth, remember, we're going to have year, and then we're going to have years until some future time. And let's look here at our situation. We have two different cash flows. One of them is a 9-year horizon, one is 3. So we're going to apply the LCM method with option B in order to make it the same study period. So we're going to use LCM. So years until year 9, since we're calculating future worth. Okay. Then we're going to have amount, FV of amount. And now this first set is going to be for option A. Now watch what I'm doing in order to merge these two cells together. When you've highlighted it, you can click on this merge and center button. So I've typed option A and I've highlighted the cell that's adjacent to it. So these two are highlighted right now, and then merge and center. And so what that makes clear is that the data I'm going to put in here and here both refer to option A. And then I can copy both of those things and just paste it here, but the next one will be for option B. Okay, so once we've done that, let's just think about what is option B going to look like when we repeat it using LCM. Let me write this on the whiteboard, and you should sketch it on your paper as well, just to get practice with LCM. So we buy the item in year 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're going to buy the item in year 0. We have to buy it again in year 3. And then buy it again in year 6. And then when we buy it in 0, we get 3 years of revenue. 1, 2, 3. We buy it in 3, we get 3 more years of revenue. 1, 2, 3. We buy it in 6 and get the final 3 years of revenue. 2, 3, and it goes through the whole 9-year sequence. Okay, so we bought it for 225. 225. We bought it again for 225. And the last time we bought it for 225. We assume repeatability. And the A for all those options was 35 million. Okay, so that's just option B on the whiteboard there. So let's translate it into the cash flow table. We're going through 9 years. And then we calculate this reverse time column because we're going to be using the FB function. So that is 9 minus whatever row we're on, tells us how many years until that future date that we're interested in. Okay, option A, amount, $220 million. Although it says AED, which is dirhams, just for simplicity, let's change it to dollars. Let's assume this is dollars. So I've done currency, and then I'm going to decrease decimal to get rid of the cents. There's already too many numbers on the screen there, so by decreasing the decimal, I'll only have it show dollars and not cents. Okay, so it's 220 million for option A, the first of 3 years, and then we have 55 million in revenue through the rest of the sequence. So that's our amount. Probably going to need to make these other columns wider as well. I'll give you a moment to type that in. Let's put in option B, the cash flow sequence itself, before we do the FE function. So minus 225 million, and then 35 million in revenue. Okay, year 3 is a little bit tricky because we've got both the cost and the revenue. So I'm going to do, rather than trying to do that math in my head, I'll type it into Excel. We can have Excel figure it out. So equals minus 225 million plus 35 million. Okay, then we're back to 2 years of 35 million, and then we buy it and have revenue again, and then just 3 years of the revenue after that. So this is what our cash flow sequence should look like for option B. Okay, so let's just keep in mind how we do the FV. Equals FV, parentheses, it starts to give us the reminders here. For rate, we always want it to look over here, so we have to anchor the reference by pressing the F4 button or typing in the $ between the B, before the B and before the 3. By locking the B, that means it would never look side to side, and locking it to 3 means it would never change the up and down to a different row. So you lock the column, lock the row, it's always going to look at cell B3 when we have $ before the letter and before the number. Okay, so comma, NPER. What's the number of periods into the future that we should compound the amount that's going into this function? And so it's not year, like this 220 million that's currently in year 0, we want it to move 9 years into the future. So this is why we've established this reverse time column, secondary time references, is so that we can put it into the function like that. Okay, put in a double comma in order to skip over the payment field because, for example, the $220 million, it does not recur 9 times. If we referenced that amount in the payment field, then what it would be calculating is the future value, assuming that there were 9 payments or outflows of 220 million. But that only happens 1 time in this table for the row that we're in. So we use the double comma to skip over the payment field, and it's the negative of the amount that we put into the function. And we put that into the PV because we're treating it as though it's a single value at the present that's being compounded into the future. Okay, so 220 at year 0, if it's compounded 9 years into the future, becomes 404 million. And now we can drag that formula down through all of the times and find the total. Okay, so the present value of option A is an outflow of about $660 million. And it says in the handout, by the way, that the shipping channel must be kept clear. The do-nothing alternative is not available here. So even if option A and option B are both negative, we're going to have to do one of them. We just want to find out which is the cheapest. Is it cheapest to do it once and have it be good for 9 years? Or is it cheaper to do it every 3? So let's check out applying the FV function here for option B. Equals FV, reference the rate and anchor it. NPER is how many years into the future we're compounding it. Double comma, because we want to skip over the payment field here. We want this individual amount we put into the function to be treated as though it's a single lump sum present value that's being compounded into the future. So it's cheaper to do option B. So I'm going to type now here the solution. If the project is a must-do, then option B is to be selected because it is least negative, lowest cost. Okay, let me highlight this as my solution, just to draw attention to it. All right. So that is the future worth analysis. We're using the future worth method. We're covering the same study period, in this case by applying LCM. And then we're choosing one of the two options and stating what our decision criteria was. All right. Anybody have questions related to just formatting? Either the formatting of the spreadsheet, or does anybody need to see a certain part of the calculations again before we move on? Yeah.
Can you show just the formula you used for the option A future value?
Sure. I'll do it over again. So formula is equals FV, parentheses, click on this, the number for the interest rate, and F4 to anchor it. For the NPR, it should be this secondary time, because that's how many years into the future we want it to compound the amount. Then double comma to skip over the payment field of the function, because the amount we put into this function, we want it to be treated as though it's a single lump sum present value. And so then minus of the amount goes into the part of the formula that it sees as the present value. So then once we've got it for one row, we can just drag it down through all of them. And then at the bottom is summing it up. Are there any other questions? Okay. Well, let's take a look at problem 2. So problem 2 says your uncle wants to make an investment and is interested in the total value of the investment at the end of an 11-year time frame. His minimum attractive rate of return is 4.5%. So there's two options. One option is that he would pay $250,000 today and then receives $33,000 each year for 11 years. And he wants to know what is the future value of that. So if you use a 4% compounding rate, then what is the future value of option A? Now for option B, we know what the revenue each year would be, but right now the seller hasn't yet quoted a price that would be paid for that investment. So what we're going to do in this is, first of all, it's suggesting to draw a cash flow diagram, what's known right now and what's unknown for both of these. Calculate the future value of option A, and then I give you a hint for this third part of it of how to find out what would be an equivalent price to pay for option B so that it has the same overall future value as option A. And the easiest way to do it is just to iterate the price paid using goal seek. So for now, start by drawing the cash flow diagram and then try and calculate the future value for option A. Okay, so in this second problem, what we're doing is trying to find out what should the person pay for the investment to have the future value be the same for option B as it was for option A. So the future value of this investment is $51,000 if the MAR is 4.5%. So what that really means is that you're making 4.5% and also having some additional profits on top of it. We'll get into more about that later, but what it's really asking in part C is what should be the purchase price in order to make these two amounts the same. So if I'm doing a goal seek, so here on the data tab, what if analysis, goal seek, then set this equal to 51,045 and 64 cents by changing the amount. So what that tells us is that by paying $181,768, then it would be equal future value for both of those alternatives. Okay, so we've run out of time without finishing questions 3 and 4. So we will pick that up in class on Wednesday. Just in case you want to work ahead on that, the solution, since I do still have a couple of minutes, let me just show you the answer. So if you work ahead on problem 3, the annual worth problem, then the annual worth will be $3,050,654. And then problem 4, which is related to capital recovery, the capital recovery of that is $15,865. But we'll go through the particulars of it in class on Wednesday. I'll see you then.